Okay, so in this problem, what you have is you have the ground level, okay, and there's a pipe whose radius is 1 centimeter at the ground level. This pipe is being fed by a pipe, that extends essentially to 5 centimeters, that pumps water out of a reservoir, and what we've been told is that the volume flow rate, which is the water exits the surface, is 0.00314 meter cube per second, and the question is, first question would determine the speed with which water leaves the hole. So we want to find the speed here, and then of course we want to find the gauge pressure. Now remember this is we're finding asking the gauge pressure in the reservoir. Okay, now a big mistake here would be to say that the gauge pressure is rho gh. Alright, now that is valid only when the fluid is at rest. Now here the fluid is clearly flowing, so the gauge pressure would not be equal to rho gh. So we need to figure it out. We're going to have to use Bernoulli's equation to do this. Okay, so let's go ahead and start by answering question 1. Okay, first is what is the speed with which it's flowing? Alright, so we're going to use our definition of volume flow rate. Volume flow rate, we know, is equal to the area times the speed. Okay, so since this has been given as 0.00314, no, 0.00314, okay, we know this is equal to pi times 0.01 square times v. Let's just call this v2 because this is going to be the v2 for the thing. If you calculate this correctly, you'll get v2 being equal to 10 meters per second. We'll take pi to be 3.14 here. Alright, now we have this. So that's part 1. Part 2 is to find the gauge pressure. Now in order to find the gauge pressure, we're going to use Bernoulli's equation, which is P1 plus 1 half rho V1 square plus plus rho GH1 equals P2 plus 1 half rho V2 square plus rho GH2. Now let us understand all the things. P2, this is all at the top, okay, and this is all for the reservoir. Great. Now for the reservoir, we know that the height h is equal to 0. It's at the bottom, so that's gone. Okay. V1 we're going to have to find. V2 we know. H2 we know. P2 we know. P2 is equal to the atmospheric pressure. We're going to find P1. In fact, the gauge pressure is simply going to be P1 minus P0. Okay, so this P1 minus the P0, and then that's what we'll end up getting. So we'll just calculate P1. Okay, but before we do P1, we need to first find V1, and to find V1 we're going to use our equation of continuity, which is A1 V1 equals A2 V2. Now A is pi times 0.05 square times V1, which we do not know, is equal to pi times 0.01 square times V2, which is 10. And V1 now is equal to simply 0.01 divided by 0.05 square times 10, and this is basically 1 divided by 25. 10 divided by 25, this is equal to 0.4 meters per second. Great. Now that we have this, we can now substitute everything into Bernoulli's equation, and we end up getting P1 plus 1 half times 1000 times 0.4 square. What happened here? Plus 0 is equal to P0 plus 1 half times 1000 times 10 square plus the rho GH term for the second part, which is 1000 times 9.8 times, how high is it? 5. Okay, so you see this is the rho GH term, and this is the the gauge pressure has a lot more things going on here. Okay, so what I'll do is I'll write it as P1 minus P0, and then the right hand side I can write as 1 half times 1000 times 10 square minus 1 half times 1000 times 0.4 square plus 1000 times 9.8 times 5. Great. The first term is 100, so 50, so it's 50,000. The second term is 500 times 0.4 square. 0.4 square is going to be 0.16 times 500, so that will be equal to 80, plus the last term is going to be 5,000 times 9.8, so it will be equal to 49,000. Great, we have all our terms. We can combine them. We get 50,000 plus this, so that is about that's 99,000 minus 80, so it is 980 no 98920 pascals. Okay, now we can also ask other questions such as, how high does the fluid reach out here at the when it comes out of the hole, and that would be a one-dimensional motion problem. Or another variation could be, you're given how high the fluid reaches, and then you have to work backwards and find the gauge pressure. So these are all variations. When you do one, you can do pretty much all of them. Okay, all right.